Okay, so let's start with a story. And if we look at comics like Garfield, we can do it with just a couple, even one or two or three items. And to start. Okay, so we can see a dot become something like a unicorn, which becomes intelligent. It can say hello and become anything that the space can imagine. So that's 1, 2, 3, and we have now solved the physics of imagination through going from story to whatever it is you can imagine. And from here, of course, we can do things like add devices that you can access this from, or such as a TV view or a goggles view, or a laptop or a gamepad, or any of the other device types, right? And we'll put a desk in there too. Okay, cool. And through this, of course, you have a sense of perspective, which now gives you a dot matrix of 3D, right? So if all of this is just a matrix of dots, and we have GPUs, which are good at calculating ray tracing, so the calculations of light beams, and can splatter dots and remember, so have memory. So we have, let's see here, dot matrix with a graphics processing unit that does really good ray tracing, splatter effects, memory, and so on. So by splatter, what do we mean? So this is to be able to, with a lot of dots, paint or splatter an image. So basically it's sending all of these dots from a cannon to make up that shape, right? And it does that over time. So if we draw a timeline of frames, we can give those frames a number or a symbol or a name or anything like that. And we can go from this large sphere, let's say that's Earth, to drawing a spaceship, let's say. So let's think of what Star Trek looks like. It's a saucer, and then it's got the engines. Okay, or the propel. I'm not sure what those are called. Okay, so now we have Star Trek. Now we have a holodeck. And now we have anything you can imagine after that. Because if we can go from the Earth and look at it as a spaceship and we have holodecks, then we can make infinite experiences from there, and ideally focus on experiences and experiments that really measurably help make people's lives better. So that would be the goal. So we can start to do how to library. Okay, so if we have a how-to library, then we can do a search field that provides unlimited books, basically. And you put the drive into the engine, and then it goes. Kind of interesting. So it's a disk. It's also a drive, or the disk goes into the drive. So we have, let me just write that down, disk, drive. We have things like speed, and so on. And then they basically needs to be able to do two things, read and write. If it can do those two things, it can basically do everything. Of course, it'd be nice if it had an antenna built in. So let's give it one. So we now have wireless capability. And we can have a battery in there. And that battery can be refilled by anything. Whatever we want. Really, we only need one wire, not three. Okay, so we have our battery, plus, minus. We have our power source, or electric. So this would be energy in. And really it can be in, out. Cool. All right, so now we have a way of connecting, filling up the battery. We have a wireless antenna. We have seemingly unlimited storage, so that's local plus cloud equals perceived. I think there's a better word than perceived. But local plus cloud equals the perception of unlimited storage or space. I like that. And from there we get into resources. So like, for instance, the ability to have memory in that space, right? So that's both storage as well as memory of things that you have, that you're working on in real time, multitasking memory, which in theory, long-term and short-term memory, with enough abundance can follow the same protocol, and just be one whole, which would be nice, and one unit. So we have perceived, unlimited space, which includes memory, graphics, so calculating, basically, calculate, process. You have light and more. Okay. So this is cool. We have a bit of a story going on here. So we teach story on how to go from a dot to a space with a unicorn. Let's give that unicorn a horn. Thank you. And we should give it wings. I'll give it even better wings later. Get it to speak and interact, and for the space to take shape with a dot matrix display that can show up on anything, as well as just a speaker. Doesn't have to always be visual. And can utilize things like cameras and sensors and so on. So you have access to perspective. So we went from just a dot to imaginative to imaginative space that's smart and intelligent enough to communicate, and to this series of dots that make up a visual graphics, right? Physics-based graphics. And all we're doing is using the latest physics calculators, which are, primarily produced by NVIDIA and AMD, and I think Intel's in the game as well, making these physics calculating boards. So we'll call that a GPU. And those boards have usually 4 HDMIs, or display ports, I should say, DisplayPort and HDMI, which means video out. Okay, which means that this can power the equivalent of 4 screens at 4K at X hertz. And it can be more than 4K lines, or a 4K resolution, I should say, a ratio, and so on. But let's just say right now we are at, instead of 4, we can call it XK, and they're all X. So they all 4 can put out the same amount of pixels, and then we would add in at what hertz. So Y hertz, Y hertz, Y hertz, Y hertz. Okay, cool. So now we have that. So now the question is, how many hertz and how many K do we need in order to create a completely working illusion? So how many K, how many hertz to get completely magical interfaces? Right? And what is the interfaces in this case? Magical light, energy, and so on. Okay? So this is coming along pretty darn cool. So we go from a dot to that to that. So what we're doing is we're creating a universal approach to bringing imagination to vivid life and interactivity, and then to do that on a network scale, on a group scale, on a global scale, on a universal scale, right? So if we can go from a personal level, family level, community level, team level, enterprise, nation, global level, and then be prepared for universal level, then we go through each of the potential areas, and we have this calculating system that follows the language of the universe, that follows math, and basically propels us, imaginative futures ahead in our current capability of doing, to where science fiction becomes science fact. And because you can use any science fiction laboratory and calculate the results and animate the results in a virtual space, when that virtual space exists as light in physical reality, all of a sudden it is now physical. It's measurable as light over time and over location, and that includes the scale of that light as well as the mass that it's taking up, or the volume that it's taking up, and the geographical position in relation to Earth, which is, the easiest way to calculate right now. So that's pretty straightforward. We have Earth, we have the center point, we have time, which just so happens to be linear and can have branching patterns, especially as we think about our memories of the past or our records of the past being branches and information that has been recorded as words on paper or symbols on stone and intellectual memories passed from generation to generation to generation, right? So we have Earth, we have time, the line of time. On that Earth, we definitely are very focused right now on the intellectual membrane, which seems to be, or at least we relate it as hierarchical life, which includes, flora and fauna and so on. Kind of interesting. It arguably is not actually hierarchical, but from a perspective of many humans throughout time, they look at it as, from their point of view, there's a hierarchy where humans have language and tool building and a responsibility to take care of the plant world and the animal world and all the various aspects of the natural ecosystem. So that's that. All right, let's do some more math. Speaking of which, hey, there's other stuff over here. Okay, so we have the art of prompt crafting, and it looks like speed or speech being key to this. Gazing is a cool word, to gaze into paper in this case, and to draw from that paper. Invention and experiences, so I'm literally drawing to life with this paper a wheel of creation here. So the wheel is constantly being reinvented. So you can constantly utilize the wheel to do everything from move a object, onto wheels, and now it skates, right? Or can go through a Hot Wheels ramp, which is pretty fun, to wheels that we can use as memory palaces and start to build and place memories deeper and deeper down the mind map. We can do it as wheels of communications and organizational charts and so on. So the wheel is constantly being reinvented. Can be invented as little menus with sub-menus or information with sub-information. So the wheel is just this beautiful physics-based mathematical, construction that exists in real life that we understand so deeply that we can use that wheel for all kinds of magical, amazing things. And we can develop that wheel and add all kinds of physics and properties and information to that wheel in order to branch out and focus on details, which becomes a lot like clockwork. So what's interesting is if you look at clocks, and I'll just do this as a wristwatch because they're tiny. Clockwork. We've stopped actually working on our own clocks, just like we've stopped working on our own cars. Kind of funny. If we can fix that and we start working on our clocks, interestingly enough, I have a computer that's over by a grandfather clock, and the inside of that computer has a lot of reminders to how clockwork works. Clockwork being fully mechanical, whereas the computer is electronic, but in essence, the electricity is flowing in a mechanical way. So if we actually think about how electricity flows through elements as mechanical instead of this concept of digital, which, or digital being part of the mechanical, just as a tool for programming and so on. I don't know what I'm getting at, but long story short, clockwork, if we can work on our own clocks and really go deep on the intricacies of what they do, for instance, a clockwork with a watch with 3 might have a date, a time, it might have a stopwatch, so stop and go, and so on. And those are 3 different mechanisms, each with a separate set of gears that all mechanically work to make that information watchable. So pretty cool. So what does it mean to watch? Okay. And if we go to the English, science, and math, what is the math and science of English? It gets really interesting really quick, because you start to see words like watch. And what does it mean to watch a clock? And what can you show on a clock? What can you watch on a clock? All right. So you can watch on a clock dates and time. You can use it as a timer with stop and go. You can also have alarm functionality, so notify. So we can save little notifications and reminders. So it's like a little bell with notifications. So now we added in a sound mechanism. And pretty soon we can do a microphone mechanism. So if you think about an old mic, somehow it was recording from a needle onto some form of a small encodable substance. So it could be dots, dashes on a piece of paper. It could be into clay and so on. But it's basically taking those vibrations inward and then storing it on time, either storing it or passing it through. And then, of course, that information that gets converted into something mechanical, including electricity, and also states of matter inside of elements, right? So tiny little ways of storing and moving cells around or information around on physical hardware at very tiny scales. That's super fascinating. Anyways, clockwork inside of a small wristwatch. And the question becomes now, my hypothesis is a small wristwatch can do pretty much everything we need it to do mathematically in order to have that pure level of wireless antenna and magical calculating for physics engines and things like that, as well as access to the network. So a little clock, a little wristwatch, you may not even need to build a large watch because the wristwatch can already do so much. But you can also build large clocks as well. And you have more space to play with, which is a lot of fun as well. Okay, so it's just this idea that I have a feeling that most of the calculations we're doing in many everyday use cases, so useful use cases for everyday use, many untapped capabilities of automation, of programming, of calculating, of holding data, all that stuff can fit easily in one person's wristwatch. So we can now have a small little product that mechanically, with electricity and so on, can do and hold and provide massive, enormous amounts of value in a very clean and clear and organized and simple way. And programmable by the person, as opposed to being programmable only by, those who create it in the first place and, those who are programmers, right? This needs to be autonomous to, or have agency of the person who's using it, so that it becomes their tool, their toy, their so on, to customize and build upon as they wish. So that provides lots of good stuff. All right, anyways, CRM and accounting being two major secretary services. We also have filing. So it's one thing to have files, but it's another thing to handle filing. And the ing is the act of doing, right? So again, the science and the mathematics of English, if we start to program with English, we can start to really align multiple programs into connected programs, right, which becomes a, let's just say, a magic mirror. That can see, it can sense, it can speak. So we'll give it a couple of speakers. So it can see, it can speak, it can hear, and so on. So we have microphones, we have speakers, we have cameras. It has the ability to connect to power and internet. So we'll do an Ethernet and a power. Boom. Okay, that could be combined as one cable. You know, it can have a battery, and so on. Oh, and of course, an antenna, and storage and whatever else it needs. Let's see here. Let's put in a little disk store. I'll put that somewhere else. Over by the battery, we can have storage. Okay, and I'll draw that like that. Give it a little drive icon. Cool. All right, so now we have this interactive device, and we are connecting in your CRM, your accounting, and your filing under a secretary type program, right? So secretary action program. It can run through here, and it can do whatever it needs to do, and it basically follows a process of giving you results. So we'll end this with real world results you can depend on. You can depend on, because the math is sound. So if we do math in this fun new way that utilizes animating skills in real time and utilizes a computer's ability to understand large amounts of language and convert that language and translate that language accordingly, interpret being a keyword of today, but really translate. Yeah, we can do amazing things and have a magical mirror-like experience where we are bringing our requests, our prompts, our imagination to life really, really quickly in a collaborative, shared way where all of a sudden, like literally overnight, everyone in the world can be connected in this very deeply imaginative and wonderful way. And it's just tapping into the physics and the energy and the light and the invention that's kind of already there, and just simplifying, you know, following the pathway as you draw that path from paper or from whatever canvas. You are literally drawing the invention to life in real time, because we have so much information of physics and story and energy and light and historical information and processes and how-tos and recipes and toolkits and fun and functions and all this stuff. Everything is so well aligned and recorded that now we can start to follow those paths of language, of recipes, of how-to guides, of encyclopedias, of math functions and physics functions and cash flow functions and more, in order to literally start in an overnight fashion, start doing real world processes at incredible flow and speeds and quality, right? So let's say that we need A plus quality. And we need that with a few checks. So let's give it a few checks. Perfect. All right. So if we write checks of the appropriate dollar amount in this case, we can distribute those dollars through a series of steps that elegantly and quickly take us to an effective, efficient result, and very predictable results. So I'm going to write that down next, is predictable results. And that reminds me, Prof. G, Professor Galloway, mentioned time machines. For instance, saving a mother whose kid has diabetes a lot of time in the transportation, driving to and from doctor's offices, learning and managing things like blood sugars, and doing the regular measurements and all that stuff that goes with a mom's responsibility to a child with diabetes. If you can help to automate and make some of those steps easier and make the child's life better and less, less dealing with the problems of that and more just handling it. Long story short, you've created time for the mother and the child. You have literally freed up time for the mother and child to be doing other things, right? Same with the family members around the mother and child and so on. Simply by saving time in the interactions that go with the process of handling your body in relation to something like diabetes or other types of issues that don't necessarily need so much time commitment in order to manage well. So that was one example of saving time. Another example of saving time is the difference between using computer spreadsheets versus paper spreadsheets. And notebooks. People could only account so quickly when all they had was paper, but when they moved to the GUI spreadsheet, all of a sudden they could do accounting much better, and people with some basic math and spreadsheet skills could do 10 days of work in one day, as an example. And that was back in the 80s. So now, of course, with 3D spreadsheets and the future of accounting, computing, we can really save a lot of time there too. So there's two examples of time machines. And I would say that prediction machines or goal attainment machines, really growth machines, or state altering. So for instance, getting a task done alters the state from before to after, right? So you have a check that says for, and you have an amount, so a number, or a currency. So we have for, we have a number, which is the amount of current, for is usually the, what is it for? The amount, the date, written, date, checked, or cashed, etc. So each of these has a certain number of properties, and yeah, that's checks, which is really interesting. Checkbook, banking checks related to task, project management checks when you combine those two together. So we'll do banking plus project management plus CRM skills. Boom. That is awesome. Okay. And that goes up to here again, action of the secretarial action of CRM, accounting, filing. I would say that banking has filing, is a absolute form of filing. In fact, that's where you get safety deposit boxes, keeping track of people's numbers, but you also have the ability to store boxes places. So I would even say that a public storage facility is banking. Any form of keeping secure your property for you would be a form of that. Pretty cool. Man, lots of good stuff here. So anyways, we have this logic gate that can be applied on a macro level as opposed to micro logic. Oh, wow. So instead of Microsoft, we have Macrosoft, right? So macro software, right? So like Microsoft has been doing everything microscopically, like literally using computer programs running through very tiny elements and transistors to do micro computing. But doing macro computing or larger scale would be like doing software for everyday real world experiences, like how does the departments of an enterprise communicate with each other? Who are the people? What are their processes and their roles? What are the things that are getting done each day? What's automated? What's not automated? What requires future creativity, and so on. You can literally map out macro physics, and I wouldn't even call that macro. I would say that you have micro smaller than us. Macro would be things like space physics and things that are larger or beyond us in that way. And then you have this like Earth level, no, like our perception level physics, our what we call the real world, the scale that our eyes see at, that level of physics. Anyways, long story short, we can create, for instance, businesses or architecture plans or whatever that takes place in this kind of relative to us scale. So I guess that gets into Einstein's theory of relativity, but we can kind of go off of relativity. And instead of really just focusing on the relativity of speed of light and things like that, we can get into the relativity of relation, of relating. What was I talking over here? Macro. Okay, so relativity of our eyesight and sense of time. And that creates our perception of reality, which to those who just kind of look around are stuck within only a small gap of reality. So from eyes, reality is based on the perception of a human body and brain through their eyes and their senses. And now they have this device that gives them even more access, right? So wireless. So now every person has access to an antenna that connects their brain to the network, right? And collectively, the Earth has a brain, a biological brain network. With elements or metallic, and wireless conduit. Right, so how does sound waves travel through air on radio frequencies and other frequencies beyond the frequencies that we hear? Pretty fascinating. So each human has a brain network and access to their network of stuff and people, and then the Earth is a entire unified network of many subnetworks of brains interacting with other people's brains, either direct face-to-face